All right. Hi, students. We are going to do a little bit of review today just to get some of the dust off before we start back next Tuesday. And the first thing I want to review is an equation that looks like this. 2x, sorry, not so great with Apple Pen, plus 5 is 15. And when we're solving for x, we're going to subtract 5 and get 2x equals 10. And then what are we doing to x here? We're multiplying it. So to undo it, we divide it. And we get x equals 5. All right, that's not too bad. Hopefully you guys remembered how to do all that. So I'll put another one up. And what I want you to do this time is try it yourself. And pause the video, try it yourself, and then watch me go through it and make sure that you could do everything, okay? So this time let's do 3y plus 7 equals 13. All right, pause the video, grab out your whiteboard or a sheet of paper, see if you can do it, and when you get your answer, restart it. Okay, so for this one, we want to get y by itself. Remember, we want to figure out what y equals. So the first thing we need to address is this one right here. So let's subtract 7. We have 3y left on this side. And on this side, we have 13 minus 7, which is going to be 6. And our y is going to be divided by 3. Divide by 3. Boop, boop. Our y is going to be 2. Great. All right. Hopefully that was a review for you and you remember. I know it's hard coming back after break. Whoa, no. All right. So let's do instead now a division problem. So let's try x divided by 2 minus 3 equals 2. All right, now we've talked about in class how we like to change this subtraction to plus a negative. If I want to get this term by itself. So I'm going to get rid of everything else. So this negative 3 has got to go. So how do I get rid of a negative 3? Well, let's add 3. I'm going to have 5 left on this side and x divided by 2 on this side. Now, how do I undo division? Well, I multiply, right? So bloop, bloop, times 2, x equals 10. All right. Good job. All right, I want to show you something. This x over 2, I want to make sure that both of you guys remember that's the same thing as 1/2 x. That's 1/2 x. X divided into 2 pieces is the same thing as 1/2 of x. All right, here we go. Race, 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 race. Eee. All right. Now here's one for you to try by yourself. Y divided by 7 plus 2 equals 4. All right, pause the video, grab a whiteboard or a piece of paper, see what you can do, and then restart the video. All right, welcome back. We are trying to figure out what y equals. So we're going to get rid of this over here first. Minus 2, minus 2. 2 over here. That leaves me with the y over 7 over here. Remember, y over 7 is the same thing as 1/7 y. Those are the same things. You'll see them written both ways. All right, I divided y by 7. So I'm going to multiply by 7 to get rid of it. That leaves me with just y on this side and a 14 on this side. All right, I hope you got that too. All right, that was our big old review. Now let's progress to some of the more difficult stuff that we were doing right before break. I want to look at problems that look like this. All right. We talked about in class how when I look at this, the first thing that I look at is I look at these and I go, ugh, no, thank you. I don't really want to deal with that. Now, could I add 3/5 and 1/5 pretty easily? Yeah, I could add those together and get 4/5 x pretty easily. And then this problem doesn't look so bad, right? That's not so bad. Trying to get x by itself, right? So I'm going to subtract 2, and get 8 over here and 4/5 x over here. Now, remember when I multiply by a fraction to get rid of the fraction, I can multiply by the reciprocal, 5/4. Look, these 5s cancels and these 4 cancels. But if I multiply one side by 5/4, I also have to multiply another side by 5/4. So I'm going to be left with x over here and 40/4 over here. Now, 40 divided into 4 pieces is just going to leave me with 10. Oh, that wasn't too bad, right? All right. If they have the same denominator, woo, hey, friend, no, go away. If they have the same denominator, it's not too bad. But what happens... That one's the same. What happens when I don't have the same denominator, right? Ones like this. I don't really want to have to find common denominators here. So we're going to use a trick that we've been using for a while in pre-algebra, where I multiply both sides by something, and it's totally fair. Remember, like, we have a scale. If I have like a 7 on this side and a 7 on this side, if I add 1 to this side, and as long as I do it to the other side, I'm good. Same works for multiplication and division. My goodness. If I multiply this side by 2 and I multiply this side by 2, I'm good. That's fine, right? Or if I divide this side by 7, and divide this side by 7, that's fine. I'm still balanced, right? So we're going to use this principle to get rid of yucky numbers on the bottom. Okay, so this is where some of this was confusing last semester for you guys. Okay, so the first thing I would do if I look at this problem is I'm looking at this, bloop, and I want to find out what x equals. So anything extra I have here, I'm going to go ahead and move. Just make it easier on myself, okay? So, erase. Let's subtract 1 from this side and 1 from this side. I'm going to have 1/4 x plus 3/5 x equals -10, okay? All right. Now, I got a 4 and a 5 over here. Now, in the past, we've talked about how I can multiply by the denominator to get rid of it. But in this case, I have 2 denominators. And if I multiply by 4, it'll get rid of this one, but not this one. So, what if I multiplied by 4 and I multiplied by 5? Now, this is really multiplying by 20, but I just have it separated out so it's easy to see, right? If I multiply by 4 and by 5, we're going to multiply this number by 4 and 5 and this number by 4 and 5. It's the distributive property, just like we've been using all year, right? When I multiply 1/4 by 5 times 4, look what happens to my 4s. Ooh. What what am I left with? A 5 on top, 5, and then I'm just left with a 1 on the bottom. Well, anything divided by 1 is just itself. That leaves you with a 5x. Oh, that's so much prettier. I like that's, oh, much better. Okay, now let's multiply 5 times 4 times 3/5. Look at this. A 5 and a 5 cancel out. Now, I still have this 4 here. So I got a 4 times 3 is 12x. And same as last time, 1 on the bottom, but does that matter? No. Anything divided by 1 is itself. Okay? So 5x plus 12x equals, now I still have to remember to do this, 20 times 10, 200. Don't forget our sign there. Okay? Now this looks so much more appealing than this. But it's really the same equation. I've just manipulated it some, right? So I'm going to get 17x equals negative 200. I'm going to divide by 17, divide by 17. X equals negative 200 divided by 17. Now that looks like a yucky answer, but this is perfectly acceptable answer in pre-algebra and algebra. Right? All right. That felt like a lot. So, woo, hi friends. I'm going to try, let's see if we can do the next one. And then I'm going to have you do some by yourself. All right. Next one. What do I see that I don't really love? The 6 and this 8. Not in love with those. I'm trying to get rid of those. So I'm going to multiply by something. But wait, hold on, what about this? Can I just multiply just this one part of the equation by a number and not multiply this one? No, I can't do that. I can't do that. I have to multiply the whole side by something. So let's get rid of this 5 first. How do I get rid of the 5? Add 5 here. Add 5 here. That's going to leave me with negative 7 on this side. 1, 2, 3, 4, oh, yep, that's right. Had a brain moment. And on this side, I'm going to have 5, 6x plus 5, 8x. All right, I don't like the 6 and the 8, so I'm going to multiply both sides by something. Now, I could multiply it by 6 times 8. Could totally do that. That's just going to leave me with a really large number over here. 6 times 8 times 7. Very big. I'm going to show you a special trick here that we use. If you know the term least common multiple, that's what I'm using. But this is a fancy way to do it. Okay, what do I need to get a 6? Well, a 3 times 2 will give me 6, right? This is going to handle this denominator. It doesn't help me with this one, though. What if I added times 4? Oh, so smart. Now I've got this, which gets rid of the 6, and this, which gets rid of the 8. Now, very cleverly, if you multiply 4 times 2 is 8 times 3, you get 24. Guess what 24 is? The least common multiple of 6 and 8. So I'm actually multiplying by, here's what we call the least common multiple. But if you think through it, when I did the 3 times 2 and then I added the 4, I didn't really even have to figure out the least common multiple. Does that make sense? Right? I got a 6 here, and then I got an 8 here. All right, okay. So let's multiply times 3 times 2 times 4, but I have to multiply both sides, 3 times 2 times 4, right? All right. First thing I'm going to do is multiply 3 times 2 times 4 times 5 6. The 3 and the 2 and the 6 cancel. I'm left with 4 times 5. That's 20x. All right. And the next one I'm going to do is 3 times 2 times 4. Oh, that looks like 32. Times 8. Okay. The 4 and the 2 cancel with the 8. And that leaves me with the 3 times 5. That's 15x. Now, over here on this side, this is where it gets more complicated. I got 3 times 2 times 4. Do you remember what I said that was? 24 times 7. Well, 7 times 4 is 28. And 7 times 2 is 14. Plus 2 is 16. So I'm going to get 168 on this side. But look, I have a negative right here. Times a positive. So that's going to be a negative. Negative 168. Okay. 20x plus 15x is going to give me 35x equals negative 168. We know what to do here, right? This is x times 35, so we're going to divide by 35 and divide by 35. Now, I know that 24 times 7 is 168 because, look, I just did this up here. I also know that 7 times 5 is 35. Watch this. Boop, boop. 24 over 5. That's a much better answer, right? If I wanted to write it as a mixed number, which I don't have to in pre-algebra, but if I wanted to for some reason, how many times does 5 fit into 24? 4 times with 4 left over. 4 4/5. That felt like a lot. Right, friends? We just take it step by step. All right. I want you guys to go back to your I'll post it on the website, but one of the assignments that I gave you, and I want you to retry it after you watch this video. In particular, problems that look like this or problems that look like this, I think might be easier. And I may put up a video later this week just working all of those problems out. And that way, if you work them out and then you get stuck, you can go back and watch it. All right. I hope you guys are having a good break.